Hi everyone, it's Albert. Today let's solve one of the most classic string questions from LeetCode, longest substring without repeating characters. And before we start, don't forget to subscribe to my channel. I'll be constantly solving good and classic LeetCode questions with clear explanation, animation, and visualization. Now let's look at the question. In this question, we're given a string s, and we have to find the length of the longest substring without any repeating characters. So for example 1, the length of the longest substring without repeating characters is ABC or BCA, and the length is 3. And for example 2, since all the letters in the string is the same, so the length of the longest substring we can get is 1. And for example 3, the length is 3, and the answer is substring WKE. And for example 4, if the input is empty, then we will just return 0. And data constraint, the length of the input string can go up to 5 times 10 to the power of 4. And this is a very important string question because it involves two very important techniques in data structure. And the algorithm is sliding window, which is 2 pointers. And the idea is we will maintain a sliding window and we will keep extending it until a repeating character appears. And the data structure we will use to keep track of the repeating characters is a hash map, where we store the character as a key and the index of that character as a value in the hash map. Now let's see the code in action. Okay, and here we'll be looking at example 1. The input string is ABC, ABC, BB. And there are a few things we have to set up first. Result is the length of the longest substring without characters we'll return at the end. And we will need a left pointer, default to -1. And the left pointer is the left boundary of the sliding window. And notice that this left pointer, it is one step before the sliding window. And we will see very soon what that means. And we will need a hash map m to keep track of the letter and of the index of the string. On the top of the code, we can handle an edge case. If the input string is empty, then we will just return 0. And if it is not, then we will iterate through the string. So the first 3 letters, they are not repeating characters. So we will just add the letters and their indices into hash map m and then update res. Now res is 3, which is the substring ABC. And left still remains at -1. But when we hit another A at index 4, it's already in the hash map, and the last index of A is 0, which is within the sliding window. It means that A become a repeating characters. And what we will do here is update A to its current and latest index, which is 3, and then move left to the last index of A, which is 0. So now the sliding window will start from B and going forward. So in this approach, we'll always set left one step before the sliding window as the left boundary. And the effective length of the substring will be I minus left. Okay, and now move I to the next letter. And B is the repeating characters, and the last B is within the sliding window. So again, we'll update the index of B in the hash map to 4, and then move left to 1. And the sliding window will now start from C. And repeating the same process, this is how it will look like at the end. And the length of the longest substring without repeating characters is 3. And this will conclude the algorithm. Finally, let's review. So the key algorithm to solve this question is a sliding window, or so-called 2-pointer. And the intuition is we'll maintain and keep extending the sliding window until a repeating character appears. And we have a left pointer that it will point to one step before the sliding window. And the data structure we will use to keep track of the repeating character is hash map. And the key in the hash map is a character, and the value is the index of that character in the string. And time and space complexity of this approach are both linear, big O of n. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.